Getting my life situated here. As you sketch out that picture of what's being described on number one, labeling out what's being done, think about the plan of attack. At this moment, we have in our tool bag for right triangles, we're going to have 4 tools there. Right now, we've got 3 of the 4 tools. 3 of our full tools. Wow, 4 tools. Try that again. Diagram theorem, and then 2 special rights. Hayden is not here today, is he? Okay, so what's our very first tool? If we can use it, we always aim to use. Somebody thinks of it. It's diagram theorem, right? That is one of our tools we try to use. Otherwise, what tells you it's a 45? What tells you it's a 30-60? If I see something in there that tells me that, then I'm going to use that. And if nothing tells me 45, nothing tells me 30-60, nothing tells me Pythagorean theorem, then my last tool I'm going to use is trig. Now, we're not trig yet. That'll be starting tomorrow. All right. So what do we have? One leg is what? X minus 2, and what's the other leg? X minus 4, and the hypotenuse is X. So which of our 3 tools are we using here? Nothing tells you 45, does it? It doesn't fall in our pattern. And also for our 30-60, nothing tells me in our pattern that this is a 30-60. Even though they don't give me the angles off that, it still doesn't fall in our leg pattern for that, nor does it fall in our hypotenuse pattern for a 30-60. Nothing tells me that. Pythagorean theorem is what we're using. Okay, set it up. Okay, set it up. A squared plus b squared equals good old c squared. A squared doesn't matter which one we call A and B. Nope. A squared plus b squared equals c squared. This is going to, again, bring back in everything that we focused on our good old quadratics. All right? Go ahead, square them out. What's the matter? You're looking at that weird. What's with you? It better be parentheses, right? You guys know me by now. I like to walk you off a cliff if you're going to follow me. All right? What is those, lemmings, I think? We'll follow everybody off the cliff. They're going back. Yeah. So, x minus 2, what? Parentheses. X minus 4, what? Parentheses. We talked about the importance of parentheses before. And then correctly squaring out x minus 2. You got some room there. We're not going to do number 2. So you can go ahead and maybe scratch out that problem, but use the white space for number 2 to do some of that scratch work if you want yourself to. All right, so x minus 2, expand it out, right? So you better make sure you're correctly squaring that. We talked about that with our polynomial work. The simple mistake is to say like x squared plus 4 or x squared minus 4, but you're forgetting the linear term off that. So as you work that out, double check me, but I believe it should be what, x squared minus 4x and a plus 4. You check your multiplication there. We've done a crap ton of polynomial work at this point, and that's just distributive property, but you should be getting x squared minus 4x plus 4. On that second one, you should be getting what? Same deal. Expand it out, distribute x squared minus 8x plus 16, right? Mm-hmm. This is old school stuff. All right. And on the right hand side, there's nothing there, is there? Just a x squared. Okay. Again, this is where we're talking about some of the differences between algebra 2 and algebra 2 honors. If you're not seeing that, I would encourage you to say algebra 2. I'm not trying to dog anybody here. I'm just saying these are seeing some of the differences between what the 2 classes you probably set up. These should be immediate things. Set it to 0. As I set this thing to 0, clean it up and put it into standard form. Hopefully realize, these x squareds combine to be 2x squared. What am I about to do with that 1x squared? Let's subtract it, right? And what's going to happen then with that 2x squared minus 1x squared? Yeah, it just gives me an x squared, doesn't it? I got some linear terms up there. Negative 4x minus 8x. And I got some constants up there, 4 and 16. That's 20, right? I've combined everything, I put that thing in a standard form, and there's our factoring coming into geometry. Factoring coming into our right triangle work. This is why I like this one for SAT. Do it out. A is 1, B is negative 12, and C is 20. Okay? Everything kind of bleeds back together. Factors of 1, factors of 20, some way, somehow, get me a negative 12 out of that. All right? So you can do your work off to the side. Again, we don't need to have to use this space over here. But as you go into Algebra 2 next year, 2 honors, the difference between those two classes is going to be Algebra 2 honors, respectively 1, basically. Algebra 2 is going to work with you a little bit more, okay? Because they're just going to work with you a little bit more working on that, okay? All right, what do we got? 120, 210, 4 and 5. 2 and 10, what do we know about our signs? Correct, both negative, right? And there we go. Now, we get our two solutions using our zero product property, which in this case, one solution is what? And the other solution is? Now, in this instance, I don't get the negative, do I? So typically we toss out, we've been getting a negative, we toss it out. But we got to think about this. I get two positive solutions. Both of them right now seem to be okay. But as I go back to this problem, I go back to the legs, which one is not going to really work out? I'm sorry?
2.
Yeah, if I plug in 2, what happens here for this leg? Yeah, is that going to really work out for a triangle? So 2 minus 2 is 0, 2 minus 4 is a negative 2. That really screws up a triangle. That's not a triangle though anymore, is it? That does not work. 10 minus 2 is what? 10 minus 4 is what? And that's a 10, right? So there we go. What solution am I going to keep? X equals 10. That doesn't answer the question though. This is what SAT does. SAT doesn't want 10. What does SAT want? The length of the longest leg. And what is the length of the longest leg? Correct. So again, SAT tends to do that thing. Yes, you got X. Be careful to answer it though. They might want that. But SAT wants you to type in usually. This would be like a type in one where you're going to say not multiple choice, but the length of the longest leg is going to be what? 8. Okay? Read the questions carefully. That's a big one there. All right? It's a big one. It's not like it's not impossible to do, but it brings in a ton of things there. It brings in our polynomial work. It brings in our factoring work. It brings obviously Pythagorean theorem. And then it goes another step with reading that very carefully. There's about 4 things hiding in that problem right there. Okay. All right, let's go. Let's move. Sketch it out, number 3. All right, sketch out number 3. Let's take that description there and sketch it out. Okay, sketch it out, sketch it out, sketch it out. All right, give you a moment to sketch this. Bring that back together here. So 12. 12, I believe, should have been the answer. Okay, now off of that really quick, let's just check here. The biggest thing with this one here is it's not usually where that 5 is at. It's where that 13 goes. And just as I was talking to Brianna back there, watching that 13, again, I'm the ladder here. If you put that 13 on the vertical leg, you just told me this. Do you put a ladder like this against the wall? Because what happens if you start climbing up that ladder,
You fall backwards and die.
well, maybe not die, but you might not have a good time.
Depends on how.
Yeah. So you might get one step up, 2 steps up, but that's going to be it. So that ladder is going to be the one at the angle which represents the hypotenuse, right? So then you guys know how to solve it out. And what is the distance above the ground that ladder is going to reach? That's that height, which you said is 12. Okay, let's rock and roll. Let's go to number 4. Okay, again, I would sketch it out. Present the what in the 45-45? It's the hypotenuse, right? So let's think about that. That's why I want to do a little bit of extra work with you here today. Okay, so as we take that off to the side, alrighty, going back to knowing those 45s, that is representative as S root 2. 22 equals S root 2. So setting that up, now solve it out for S. How do we solve out for the side? Yep, divide. And unfortunately, this is the one we're going to have to rationalize the denominator. Rationalize that denominator. Okay? As we rationalize that denominator, we did, again, all that work last week. We get 22 root 2 and a perfect square in the denominator of 4. And the perfect square of 4 is 2. Now, off of that, that looks great, but we can usually do maybe one more thing. Reduce. 22 over 2 becomes, right. So the side of that square with that particular diagonal is 11 root 2 all around. Okay? Once you get the side of the square, you've got the perimeter, you've got the area. This one, you got to get the what? Side first. And every square contains a 45s, contains isosceles rights. Now, you got the perimeter, cool. What is 11 root 2 times 4? What's 11 times 4?
4.
Square root of 2. That's it. Okay? So we have 4 sides, 11 root 2. So remember that 4 does not go inside the radical. Now, simplest radical form. Very beginning of the year. I asked you what's the area of a square. A lot of you told me length times width, base times height. I said, that's okay. How do I want you to think about that? Side squared. Right. Thank you. So, what is 11 root 2? Squared, and we're using those parentheses all over again. 11 root 2 squared is a nice whole number, which is? Yeah. It's a number. It's not a negative number.
Yeah.
What's 11 times 11?
121.
121. What's root 2 times root 2? It's 4, right?
Yeah.
And the square root of 4 is 2. So 121 times 2 is 242. Right. So all that work, again, your calculator obviously can do it for you. And whenever you multiply something by itself, your calculator can do it for you. It's not going to return a decimal. Because you're squaring it, it's going to create a perfect square. And it's going to give you 242 in this instance. Okay. 242 units are squared. Okay. Alrighty. Let's watch my time. Let's do the pile up. Okay. All right. We got a lot of things mixed in there, don't we? We're going to go find that x. All right. I'm going to give you a couple minutes here to figure out what the heck to do on that one. Give you a couple minutes there. All right. I got some of you that were realizing that there's a second 3060 hiding in there, and that's the key. And some of you are working on that now, so let's check each other's work then. Okay? Down there, 30, you got to realize that's a 60. And then right here, that's 90. Those are complementary angles. There's an additional 30, and that's that second 30, 60, 90. As I told you, I always like to separate just because things get a little busy. And what is that? 30, 60, and there's that 7 right here. Now, I'm going to go take that 7, as I saw a lot of your papers, fill it out. If that's 30 and 7, what's that going to be here? 7 root 3. And then that's the hypotenuse, which is 14, right? Okay, throw that back to the big picture. Now what happens here is that 7 root 3 I don't think really is helpful for us. But this 14 takes me to that big old 30, 60, 90 triangle, which is nice. Because that 14 and that big 30, 60, 90 triangle is part of this big triangle. So as I'm looking at this big triangle now, that I've highlighted in blue, that 14 you just found is across from the 30, which is what we always want. Across from the 30 is X, the short leg. Here's the right angle. There's the hypotenuse. Double it. 14 doubled is. Boom, that's 28. And that big triangle is what type of triangle? The big triangle is a 45, 45, 90. Reset your brains. 45, 45, 90 is S, S, S root 2. 28, 28. 28 root 2. Okay. It's a nice one. It's obviously a composite figure, brings in quite a few things. Okay. All right, let's take a look at the back. Let's go with, say, one more here, number 7. Sketch out the picture for number 7.